Hi friends, we welcome you to yet another session of Quant at Educationnest. The topic that we're going to cover would be ratio and proportion. Ratios and proportions is a topic which is well understood and applied appropriately, which can reduce our time to do problems in many cases by at least 50%. Let's look at this module which helps us with the basic concepts of ratio and proportion. So, we use ratio and rates to solve our real life problems, and also solve proportions is the objective of this module. What is ratio? Ratio is the comparison of two numbers written as a fraction. Let's take an example. Your school's basketball team has won 7 games and lost 3 games. What will be the ratio to wins and losses? Because we are comparing wins to losses, the first number in our ratio would be the number of wins and the second would be the number of losses. So, what will be the ratio? That will be games won upon games lost. So, how many games did we won? That were 7 and the lost games were 3. So, that ratio comes to be 7/3. Now, in a ratio, if the numerator and the denominator are measured in different units, then the ratio is called a rate. A unit rate is a rate per one given unit, like 60 km per 1 hour. Let's take an example. You can travel 120 kilometers on 60 gallons of gas. So what is our fuel efficiency in kilometer per gallon? So now if you want to calculate the rate, it will be 120 kilometer divided by 60 gallons. That comes to the efficiency of the fuel would be 20 kilometers per gallon. Now let's see what is unit analysis. Writing the units when comparing each unit of a rate is called unit analysis. Now we can see that you can multiply and divide units just like you would multiply and divide numbers. When solving problems involving rates, you can use unit analysis to determine the correct units for the answer. Let's understand by this an example. How many minutes are in 5 hours? So, 5 hours into 60 minutes because 1 hour has 60 minutes. So that will be 5 hours into 60 minutes divided by 1 hour, and that comes to 300 minutes. Now to solve this problem, we need a unit rate that relates minutes to hours. Because there are 60 minutes in an hour, the unit rate we choose is 60 minutes per hour. Now let's go with the proportions. As we all know, different quantities behave differently with respect to other parameters. Their relationship could be expressed as proportions. So what do we conclude? An equation in which two ratios are equal is called a proportion. Now we can see that a proportion can be written using the colon notation, which is like A is to B, and then we have the proportion sign, and then which goes C is to D. Or as the more recognizable and usable equivalents of two fractions could be written as A upon B is equal to C upon D. Now let's understand what are extremes and means. When ratios are written in this order, then A and D are called extremes, which are the outside values, and B and C are the means, which are the middle values of the proportion. So we have in front of us explaining how A and D are extremes and B and C are means. And the ratio can also be written as A upon B is equal to C upon D. So I do see that the extremes, one is a numerator and the other is a denominator, just cross towards the proportion. To solve problems which require the use of proportion, we can use one of the two properties. What are those two properties? Let's discuss about reciprocal property and cross product property. Now, reciprocal property, if two ratios are equal, definitely their reciprocals would be equal. Let's go on to the other property, which is cross product property. The product of the extremes equals to the product of the means. Let's take this example. We can see, as per the example, the original proportion is 5 upon 3 is equal to 35 upon x. So if we use the reciprocal property as we understood in the previous slide, it gives us an equal ratio between 3 upon 5, which goes equal to x upon 35. And in order to solve the problem and get x, the value of x, let's multiply both the sides by 35 to isolate the variable and then simplify. So by simplifying, we get the value of x is equal to 21. Now let's move on to few more concepts based on ratios. Duplicate ratios. A square is to B square. Example, if ratio of two sides of 2 square is given, then duplicate ratio is ratio of area of squares. What is triplicate ratio? A cube is to B cube. Example, if ratio of sides for 2 cubes is given, then triplicate ratio is ratio of volume of cubes. Now let's discuss what is direct relation and inverse relation. Direct relation. A and B are in direct relation if the increase in value of A also increases the value of B, or decrease in value of A also decreases the value of B. That means increase in A is equal to increase in B, decrease in A is equal to decrease in B. Example, A is equal to B3 plus 5. Now let's discuss what is inverse relation. A and B are in inverse relation. That means if the increase in value of A decrease the value of B, or decrease in value of A increases the value of B, then the two variables are in inverse relations. Example, A is equal to 10 minus B5. Direct proportion. A and B are in direct proportion if increase or decrease in A produces a proportionate increase or decrease in B, or vice versa. In other words, the ratio of A and B is a constant. If A is to B, then A is equal to KB, where we take K as a non-zero constant and is called constant of variation. So A is equal to KB is called the equation of direct variation. What is inverse proportion? A and B are in inverse proportion if increase or decrease in A produces a proportionate decrease or increase in B, or vice versa. In other words, the product of A and B is a constant. Now let's take a problem. Strategy of solving CAT problems. Plugging in techniques. Now in some questions which are given, where only variables are given in the question as well as options, we can use this technique to get the answers. Following are the steps. Plug in the value of variables according to the questions. Solve the question by plugging variable values and get the answer. Plug in the same values of variables in options and eliminate the choices, which have different answers. If more than one option has the same answer, then plug in different values of variables. Repeat until you get a unique option. Let's do an example with proportion. 2 upon x is equal to 6 upon 9. So if we go by the cross product property which we learned, that gives me an equation as 9 into 2 is equal to 6 into x. And if we multiply both sides by 6, we get a value of x as 3. Now let's try this question. If the average person lives for 75 years, how long would that be in seconds? Let's look at the solution. To solve this problem, we need to convert 75 years to seconds. We can do this by breaking the problem down into smaller parts, converting years to days, days to hours, hours to minutes, and so on. So there are 365 into 25 days in 1 year, 24 hours in 1 day, 60 minutes in an hour, and 60 seconds in a minute. So that will be 75 years into 365 into 25 days by an year. Then you multiply that with hours upon day into 60 minutes upon an hour and 60 seconds in a minute. So that gives me the answer to the problem. Now multiply the fractions and use the unit analysis to determine the correct units for the answer. Let's move on to one more example. Let's try this question. John constructs a scale model of a building. He says that 3/4 feet of height on the real building is 1/5 inches of height on the model. What is the ratio between the height of the model and height of the building? If the model is 5 inches tall, how tall is the actual building in feet? Can somebody think how to solve this question? Now, let's see the pieces of information related to ratio in this problem. It says, for every 3/4 feet of height on the building, the model has 1/5 inches of height. So therefore, the ratio of the height of the model to the height of the building is 1/5 inches upon 3/4 of height, which will be in feet. So that will be equivalent to, if we solve that, it comes to 4 inches upon 15 feet, which is called a scale factor. Now, if the model is 5 inches tall, how tall is the actual building in the feet? To find the actual height of the building, let's use the ratio from the previous step to write a proportion to represent the question above, which will be 4 inches upon 15 feet is equal to 5 inches upon x. Now if you use the cross property and isolate the variable, we get the answer as 18.75 feet By this, we come to our session end of ratio and proportion. Thank you.